today we're going to be making our learning target, or I'm sorry, our review video for section 11.7. That's chapter 11, section 7. And we're going to be looking at our learning target. Our learning target for today is to display data in stem and leaf plots and to interpret the data in stem and leaf plots. So let's look at the definitions here. First definition is, what is a stem and leaf plot? A stem and leaf plot is used to condense a set of data where the greatest place value of the data forms the stem and the next greatest place value forms the leaves. We'll do lots of examples. That'll make sense in just a minute. The stems, so the digits in the greatest place value of the data, are used for the stems and the leaves. The digits in the next greatest place value form the leaves. And last definition here, back-to-back stem and leaf plots. Two sets of data can be compared using a back-to-back stem and leaf plot. And again, we'll do more of those examples. So let's go jump right in and do one here. First thing I need to do is look at this data and determine which value has which value is the smallest. And you can see I've actually got 2800 twice, but that's the smallest. And which value is the largest, and the largest is, it looks to be 3,500 is my largest. So the place value of the highest place value in the smallest number becomes my first stem, which is 2. And then the next place value in the next highest, or in the highest rather, becomes 3. Right? So then every time, so that becomes my 2 stems. Now my leaves, I've got 28 is my lowest, so I've got 2 8, that means 2,800. I've got that actually twice, so I list it twice. The next one I've got is 29, so I list it. After that, it looks like I run out of the 2's in the thousands place, so I need to move to the 3. I've got 30, 3,000. I've got 31. I've got 32. Actually, I've got 32 twice. And I'm sorry, I've got 32 3 times. And then the last one that I have is 35. So I'm going to count to see how many I've got here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I did find them all. I've got them all listed there. And my key to show how this is read, 2/8 equals 2,800 is my pounds per acre. That's my key on how to do it. So I've displayed the data here. We're going to go on to the next one, to the next slide here. And here the data is displayed for us, but we're asked to determine which one is correct. So again, I'm going to start and say, what's my smallest value? It looks to be my smallest value is 58. And my largest value is 73. So I'm going to make a stem and leaf plot here. I'm going to go 5. There is a 6 and there's a 7. All right, if I go 58, so it'll be 5, 8. And then that takes care of this one. There is a 5, 9, 59 home runs that were hit. There is, the next value is 60, so it's 6, 0. Then it looks to be, I've got a 6, 1. And I've got a 6, I do not have a 6, 2, but I do have a 6, 3. And a 6, 4. And a 6, 5. And a 6, 6. And then I go to the 7. I've got a 7, 0. And I've got a 7, 7, 3. That top value is 3. All right, so there's my stem and leaf graph. And of course, my key here means that 5/8 is equal to 58 home runs. 58 home runs. That's what that means. As I look and compare these, this one does not include 7, 0, so it isn't that one. This doesn't include 6.5 or 6.6. This one includes 7.4 and 7.5, and there's not any 7.4s or 7.5s. So the only one that's possible is letter A, and that's my graph. Looking at graph, the second one, the stem and leaf plot lists the percentage of people in each state in 2004 that were born in Mexico, rounded to the nearest whole number. Which interval contains the most percentages? Well, if I look at this, I've got by far the longest one out there is this one, and it even spills over into the next column. So I've got 0 3 times, I've got 1, all of these. So the percentage from 0 to as big as it could be is 9. So the range from 0 to 9 is the largest. 0 to 9 is the largest. What is the greatest percentage of people living in the U.S., in one U.S. state that were born in Mexico? Well, that would be the bottom one here, which would be 74%. 74%, 7.4. All right. And the last question on this page, what is the median percent of the people living in one U.S. state that were born in Mexico? Well, I want to look back at my data. My data here, if I counted all these, I've actually counted them all. There are 49 of those. So I'm going to start coming down from the smallest, and I'm going to go 24 down, and then I'm going to go 24 up from the bottom, and that leaves me with the 25th one is right in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That means 22% is the median. 22% is the median. And so that's the answer to this question, 22%. All right, moving on. What is the range of this data? Well, the lowest value here is 0%. The highest value is 74. The difference between 74 and 0 is a range of 74. Next question, what is the largest percent of people living in one U.S. state that were born in Mexico? The largest percent of people living in one state that were born in Mexico, I believe, is 74%. I want to look back because I think that's the same question that was on our previous slide. What is the greatest percent of people living in the U.S. in one U.S. state that were born in Mexico? So it is the same question. Better get the same answer then, right? See, what is the percentage? What percentage occurs most often? Most often. Well, I've got 0% 3 times. I've got 5% 3 times. I've got 8% 3 times. I've got 43% 3 times. Did I miss any in there? So I think those are my ranges: 0%, 5%, 8%, 43%, and I think those are the most common. Okay. Let's see if there's another question. All right, and let's go on to the next slide then. Agriculture. The yearly production of honey in California and Florida is shown in the years 2000 to 2004 in millions of pounds. What state produces the most honey? Well, California produced 17 million pounds in one year, and then the next year 28 million pounds, and then, I'm sorry, 24 million, then 28 million, then 31 million, and then 32 million. If I add those all up, I think I get 132 million pounds, 132 million. I do the same thing for Florida. Florida got 14 million one year, 20 million plus 20 million plus 22 million plus 24 million. And that would be all. If I add those all up, checking with my calculator, they got 100 million. So 100 million, so that means California produced the most honey in any of those years. Which state has more varied production? In other words, what was the range largest? The range went from 32 to 17. So 32 to 17. shows a difference of 15. So California had a range of 15. Florida, 24 to 14, had a range of 10. So California had the greatest range in production. The last slide that we're going to do, talks about babysitting, the amount of money Hannah and Jasmine earned babysitting in 2006 is shown in the back-to-back stem and leaf plot. Who earned more money? Well, I can see that Hannah made $10 plus $10 plus $20 plus $20 plus 22 plus 22 plus 25 plus 25 plus 28, and then she made 30. If I add all of those up, I think she made $212. And if I do the same thing for Jasmine, she made 10, then she made 12, and then she made 13, and then 15. She made 20 and 20 and 25 and 30 and 32 and $40. And if I go through and add those all up, I find out she made $185. So that means Hannah earned the most money. Hannah earned the most in this. Thank you.